while people are downloading OpenCV, I'll just say a little about. This is about face detection and recognition with OpenCV and Python. And actually C++ as well, because I didn't get to translate one of the scripts, but it will be okay. Hi, Mihai. Computer vision engineer at ShortByte. The director at LocalHackDay. Most of you, all of you actually should know about LocalHackDay. It's awesome. So it's a hackathon we organized in April. We'll organize it again in December and March. We had a ton of attendees, like 200 something. And also students at the University of Manchester. Okay, so what are the uses of face detection and recognition? One of them is human-computer interaction. So you sometimes want computers to understand when they have a person in front of them. Person identification and security. That is, for example, the new payment methods using face recognition, which I don't trust personally, but they are there, and there's a lot of research in the area. Statistics, so stuff like gender statistics, how many females versus how many males will go into whatever building. And last but not least, we all hate surveillance. But face recognition and detection is used in surveillance. It is used on street cameras, it's used pretty much everywhere. So how do we detect faces? And this will be a small brainstorming session if I'll be able to make that work. No markers. Markers. Okay, so this will be a little brainstorming session in which I'll ask, what do you think?
I'll go get your markers.
Sure. What would you use for face detection? What do you think are the ways to detect faces in images?
Scanning similar objects.
Okay, so it's scanning some of the objects. I'll submit the markers. It's not really.
Using marker?
Using markers, well, so by using markers, what I think means is you have something that's already known, like say a QR code, and you put it on your face, and then you can recognize that because you already know it, right?
But online I saw some people using black markers just to mark themselves.
Oh yeah, yeah. So exactly, it's this kind of stuff. You know that there are a couple of features. So this is what we're looking for, features. You might have features that are already known, like 2 dots on the face, and whenever you see 2 dots and you know the distance between the 2 dots, you can say, hey, that should be a face. I don't think I'm allowed to stay.
I guess there's a box on it outside.
Oh, cool, submissions. No.
These ones?
Oh, I'm not sure. So we're looking for features. what kind of features does a face normally have without using markers, so additional stuff?
Eyes.
Eyes, nose, yeah.
Ears.
Yep. So what we're actually looking for when we're trying to detect a face is not, say, I want to see a face, but I want to see something that has the following features. And then you can just go a bit on a lower level and you say, okay, so if I detect something that has eyes, nose, ears, whatever, then it's probably a face. Okay. Cheers. So, markers. I don't know if you can see.
You can zoom out. There's a
Zoom out.
Yep. So, features. Ignore my horrible handwriting, I know it's. And those are eyes. Oops. Nose. Scroll. Okay. Any other ideas?
Everybody smile.
Smile. What if you don't smile? Do you detect that?
Eyebrows.
Okay. I think it's part of eyes. Is it? No? Okay.
Chin.
Huh?
Double.
Oh, yeah. Okay.
facial structure.
Hair.
Facial structure.
Okay, so facial structure, what do you mean by facial structure?
You might have like a
Circular
chisel,
triangle.
chin
Yeah.
legs
Okay, yeah. So the way we are doing face detection is something called, okay. They're called par-like features. And the idea behind par-like features is that what you do is you define a rectangular region in the window, so in your image, and that would be, say, stuff that you could recognize as a rectangle, or you could fit in a rectangle. And usually faces, most faces, do fit in a rectangle. Then what you need to do is you sum up the pixel intensities in each region. So what this actually is you know that pixels have, like the brightness of the pixels, and different regions of the face have different brightness for the pixels in that region. So what you need to do is define that region, sum up the pixel intensities, and then make the difference between the two regions. And if this sounds a bit abstract right now, I'll give a couple of examples, and I hope that will clear it up. Also, if there's anything you don't understand or you want a question, just raise your hand or throw your phone at me or whatever, and I'll be happy to answer, especially if you throw the phone. Okay. And then when you have this difference between the regions, you can assign labels to the regions. And then you say, well, this is the region of the eyes, this is the region of the chicks, whatever. And how is this useful in detecting places? Well, just what I said. One of the things we know about faces in most photos, well, unless you have really, really crappy light or it's too bright in some part or whatever, then the region of the eyes will be most of the times darker than the region of the cheeks. So what you want to think about, what you want to search about in your image is region that is a bit darker, and then just adjacent to it, you'll have a brighter region. So I'll run a couple of examples. Hold on. This will be hard to see. I don't know if you can see much there. Zoom in. Don't remember how to do that.
Go to view.
Something plus.
Right click and it says zoom.
Sorry?
Right click and it says zoom. See,
Okay.
Zoom terminal.
Yeah.
Yeah.
Yeah, it's this one. Is there something I don't get? Okay, so I'll just, yeah, try that. Yeah, I tried that before. Yeah, okay, I'll just help you see, because it's not much. I'm just running the Python script I made. So it's, okay. And now it should be. Paste that. I have an images folder. Actually, I think I should show the images folder already, because this. This will probably be fun. So those are some of the images we'll want to do face detection on, and it will work really well on some of them. On some of them, it won't work that well. And I'll try to ask you, and you'll help me figure out why they don't work as they are supposed to. So the first one is terminal. Oops, just a second. Yeah, but I have a couple of them. Yeah. Okay. So can anyone tell me what's wrong with this image? So it's obviously not the heads being mixed up.
Their faces are.
Yeah.
His eyes are not beautiful.
Yeah, exactly. So the problem here is that for some reason the algorithm fails to see his eyes. Well, with his I don't mean either of the huge kids, whatever. And the problem, obviously, you can see is that he has glasses, so it probably reflects light. So it's quite different from the other eyes in the image, right? Let's try another one. What else? What do you want?
The minions.
Okay. So with minions, it's not supposed to detect any face, and it doesn't. And again, this is because, well, one of the things you're looking at when you are searching for faces is colors that are plausible in a human face. And this is, well, maybe, but not most people. Also, most people are not sight sensors, again. Okay? Okay. This is actually. Why do you think it fails? So, right there, what you have is it detects two faces. So those two squares are for the two faces the algorithm detects.
Reflection.
Sorry?
Reflection from the eyes.
No. No, it's quite a, well, it's okay. But sorry? Yeah, so that's one of the problems. The face is staying on it. And most faces, well, in most of the photos, you won't have that kind of angle. It's also that, well, part of the thing, part of the head is a bit cut. So it's the angle, it's also the face is kind of elongated, if that makes sense. I have no idea why it detects an eye as being a face, so I'm not sure why it sees those two things as faces. But the reason it doesn't detect the actual face, as I said, is the angle, and it's just not what you would normally expect from a face to look like. Okay. Some more? Okay, do you want that? There we go. So it obviously doesn't detect any face. The reason why I think it detects that stuff as a face is because exactly. So it's the different in the pixel color. So you can see on his shirt, whatever that's called, you have the shades. So you have exactly the thing of the adjacent bit that's darker and then the lighter one. Yeah. I have an interesting one, just in case those were boring. Whoops. Okay, kids will come later. It's cool as well. Now it's. So, yeah. So it does detect the big face, it doesn't detect the small one. Or, well, the face, so to say. This is an example where what you have to do if you want to detect both faces. It's also like the reason the eyes are not detected is that, well, the thing is that it has like the dark cape on his head, so you expect the eyes to be the darker region, but then you just have something that's much darker than the eyes just above. So it won't detect the eyes. Okay? So what you have to do if you want to do proper proper detection with this is just you have to play with the parameters. Okay? Okay, one more. And then we're back to the slides, and I'll start explaining a bit. It's going to get a bit mathematical at some point, but I'm trying to make it as clear and easy as possible. Okay? So, but yeah. Can anyone tell me why it detects the bottles? Well, it's actually really good at bottle detection. I didn't expect that. But why do you think it also detects bottles and sugar, whatever? Sorry? Yeah, must be drunk. That's a good answer.
Skin color,
Sorry?
skin color.
Yeah, so that's one thing. The skin color, like it is plausible for the skin to look like the background. Yeah, like brown. Okay, so back to the slides. If I can find them. Yeah, no. Power light features. Okay, so the way, first of all, does everyone know what a classifier is? Okay. I'll clarify just in case. So a classifier is basically a program that assigns classes to various input data. So, for example, right now, it could tell faces from bananas. You would give it a ton of faces and then a ton of bananas, and tell the algorithm, well, these are faces, these are bananas, and then whenever you give it another face or another banana, it will say, well, this is a face, this is a banana. I don't know why I gave that example. Okay, so code time. Has everyone managed to get OpenCV? Yeah? No? OpenCV? Okay. So in your, where was it? So in your in your OpenCV installation folder, you should have the samples. Is it? Let me just see how it is on my machine. Yeah, so you should go to your OpenCV installation folder, and then you should have a data folder there. Okay? And
Build and sources.
build and sources. You're using OpenCV 3.
No.
Okay, are you on Windows or Linux?
Windows.
We have one data in sources.
Then search either build or sources for, I think it should be in build, but also search sources for data. But yeah, fuck this shit, let's go. So for those of you who haven't used OpenCV, it's really easy to include in Python. You just go import CV2. And then what you'll have to use is CV2 cascade classifier. And you'll have to do a bit of Googling about how you use it. Okay? Oh, Python. Just if you're not comfortable with
Python, you can ask me, or you can do that.
cool. So I'll go back to this slide. This explains what you basically have to do. So you'll need to include OpenCV. If you don't know how to read an image from OpenCV, that's just cv2.ionread. Okay. And I guess I could also do the same thing here, but just to give you some tips for the beginning.
How do I do it? Because you also need these slides.
Does anyone need help with getting started? Yeah? Yeah, in a second. Yep.
So you don't have to open those files as in double click or open them. You will have to load them through the testing classifier.
So the cascade classifier is part of OpenCV, which can include, say, import CV2. No, it's already done. So that's already there. What you have to do is you fire up whatever your favorite editor, and start writing the Python file. Yeah. Yeah. Well, yeah, you can either do that or just write an actual Python file. Yeah. then you have a bunch of classes, a bunch of things you can use. One of those classes is called cascade class, which you call, say, CDP.cascade class. Yeah, you say, yeah, so I guess I'll just do it in front. Sammy, you know how to zoom? I try to just zoom. Is it on?
You guys see what's
Okay, so the first thing you want to do is just say import open. I can. You also want to import something called NumPy, which is the numbers library of Python. do next is already to call, actually make an instance of the classifier. So that is, for example, base cascade equals, I guess to do that, you can write it correctly. Yeah. Equals CV2 dot cascade. And then the data, the argument you will have to give to this function is not that. Good. Is that thing, so data slash r cascade, whatever. So that's the argument you want to give to the classifier. And what happens there is someone already put a bunch of images through the algorithm and got an XML file which tells the classifier what the features are for positive and negative examples of faces. So basically images with faces and images without faces. Okay? So you want to load that because that will tell the classifier how to distinguish. Okay? And then we'll have to do the same thing for the eyes. So you'll have to go face cascade is OpenCV cascade classifier and have data blah 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 in parentheses. And then the same thing for the eye classifier with the second one. Okay, so I'll just do that. I hope. I can't find that term. It's horrible. Yeah. Okay. So it's cascade classifier. I'll just copy paste from here. The data. Yep. And then the eye cascade is same thing for eyes. Okay, so you're getting kind of bored, so I'll just show you the actual code, and I'll also run it from the video. So you should be able to. So this is the full code. I'll just explain it if I can see it a bit. So is it good anyone?
opposite. Yep. So what I'm doing here is import NumPy, which is the numbers library, which contains a ton of really cool functions for manipulating stuff like matrices and all sorts of mathematical functions. Import CV2, I imported a system because I was doing something with it. And then you have base cascade and I cascade, which are just basically loading the train data in the classifier, okay? Then the if else is just if I have arguments for the program, then I'm loading the image from the arguments. If not, I'm just loading the WAP image. I make it grayscale because it's just so much easier to see the darker and lighter bits in grayscale. But it also sometimes screws up your accuracy, as you could see on the previous example. Okay. Then IAM show is just showing the image faces. That's where the detection happens. So it's just face cascade and detect multiscale. Detect multiscale is for looking kind of in depth. So if you would just normally detect, you'd expect all faces to have the same size. But when you do detect multiscale, then the algorithm assumes that the faces will have different sizes. So you'll be able to detect all faces, hopefully. And then the parameters, faces, I just forgot to comment the others, but they don't matter, are, well, the first one is the image on which you detect, which is the grayscale image. And then you have some parameters which are basically, you just have to play with them to see which get better results. The first one is how much should it go in depth. So, for example, the image with the guy with the face and then another face in the chick would have been detected if I would have adjusted that parameter accordingly, so it looks more in depth. Okay. Okay. So what that yields is a tuple. A tuple is basically kind of like an array in Python. It's just like you have X, Y, W, and H. So X, Y, W, and H are for the points in the. So when you want to do a rectangle, you'll have the points at the top here, at the bottom. So you'll have the points at the bottom, like this.
Which one is it?
As you have the rectangle. This will be X, Y, and then this will be X plus W.
Okay.
Y plus H. So that's basically, you get the X and Y for the bottom point, which is this one. And then you get the W and H, which is X plus W. So it's X plus the width and Y plus the height. So you can get the other quarter. Okay? So we have that. And now what you do is you just go over all the faces detected and draw a rectangle. So cv2.rectangle basically just draws a rectangle on the area. And then ROI gray and ROI color is basically getting the face as being the region of interest, because you will only look at the face when you try to detect eyes, right? So this way you can improve, well, you can improve the accuracy, you can also improve the speed, because you don't search in all the image, you just search in that particular area. And then you do the same thing with eyes, and that's it. So just, I did that file a bit. I can't really see it there. So I did it here, just so I can read from the camera. And actually, yep. Okay, let's do all I did here is, instead of the image, I put the, yeah. So instead of the hard-coded images, I just get the stream from the camera, and then I'm processing it frame by frame. And sometimes it can see my eyes, sometimes it can. Okay. So there's that. Oh, again. Okay. Fair enough? Okay. Cheers. Running a bit late, so I'll kind of juggle through the rest of the slides. I'm sorry. So, whatever, you can see this later. So face detection is easy, but how about recognition? I probably won't have time to just explain recognition properly. It's quite a lot of that. But yeah, Sammy, do I have time for another very short brainstorming?
No, but if you want to,
Okay.
if you want to brainstorm with Mihai, whatever, and like want to build this stuff, we have his own lecture theater. You either can do the seminar upstairs, or you can go to one of those brainstorming rooms. Just help yourself.
Whichever is better.
Take whatever you want.
See?
So maybe you want to be there. That's the answer.
Yeah, so I'll
So
just finish the...
finish
the-
it.
yeah. So, yeah, you can do face recognition using hard classifiers, and this was supposed to be a brainstorming bit, but the reason is because you can only detect kind of generic features using hard classifiers, so stuff like this, the chin and the eyes, and the difference between pixel intensities. But when you have to do actual recognition, getting pixel intensities is definitely not enough, because any face can have the features of whatever pixel intensity. You can't have pixel intensities that are very specific to one face, unless you have like a fully fluid head or something. So how do you do it? Yeah, it's magic. It's magic because I won't explain the whole math behind it. But what you have to do is something called idiom faces.
And eigenfaces rely on a lot of maths. Again, for whoever is interested, I can explain it afterwards because we don't have time right now. But what you have is an eigenvector of a square matrix, and that is something that can scale or in any way distort the image, and then if you multiply again with the inverse of the eigenvector, then you get the image back. Not sure if that makes sense, saying it just like that. And then the eigenvectors are derived from the covariance matrix of the probability function of the high-dimensional vector space, blah, 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 shit on that. Yeah? That is basically what you do is you'll have, say, something. You'll get his pretty face, yeah, and say take like 10, 11, 100 photos of his face. And what you'll have is you get the regions of interest, so for example, nose, eyes, chin, whatever. And from multiple photos from very similar angles, you can get the average of that. So you'll see how Sammy looks on average. Yeah. And then what you want to do is, if I give you a photo and I have loaded the average face of Sammy, then you get each bit, like the nose, the eyes, each bit, and you see how close is that particular photo in that region to the normal face of Sammy. Okay? So then you will have like weights on which are the most important features. So if the algorithm is very sure about how his nose looks, then his nose will be very important in the algorithm because the algorithm is very sure that that's the way the nose looks. On the other hand, if the algorithm is not very sure about the eyes, then it won't have that much weight. Try it again afterwards if you like. And thank you. We were supposed to have a Q&A. It was that is like roast.
We apologize for the delay. Mihai had a lot of awesome stuff to Mihai had a lot of awesome stuff to say, but he ran out of time. Next we have network security with Mihai as well, just to make things confusing, and Esteban in this lecture theater, and building iOS, Android apps using React Native in the other lecture theater. So React for building mobile apps in the other lecture theater, and stay here for network. Thank you.